pepperoni here, we have 2, 4, 6, 8, 9. So we put 9 factorial, this is not the answer lah. Okay? Because there are distinct letters there. So you realize that you have, if you this is what I'll usually do. P, you have 3P. Then 2 is RONI. Okay? So this is it. You have pepperoni. Okay? So what to do this here? Now, why is not 9 factorial? So that's the main thing you must understand now. Okay, so let me explain to you why this is not 9 factorial. Okay, let's go down to the easiest way first. So let's say if you want to arrange 3 distinct objects. So arranging 3 distinct objects, how many ways are there? It's just, the answer is just 3 factorial, right? Which is 6 times. So how do we make sense of it? So to make sense of it, let's say we have 3 distinct balls. So how if we list down all the cases here, say I have here like that. So these are all the possible cases I'll get for arranging 3 distinct object. So here to like that. Okay. These are all the possible arrangement. 1, 2, 3, 4, 5, 6. Okay, be quite okay. Now, say now this is like 6 ways. There's a 3 factorial way lah. Okay, which is correct. We all happy, right? Happy you count 1, 2, 3, 4, 5, 6. Now we want to arrange. Let me just take this out. Let's say now we want to arrange 2 identical plus 1 distinct. What's a sensible thing to do? What's the sensible thing to do? The sensible thing to do is go to each case, take 1 ball out, and change to an identical letter, right? So let's say I go to this case here, I take the green ball out, I replace with the orange. Then I replace the green color with the orange also. I replace this green with orange, orange, green with orange, green, orange. So this should be 6 cases, right? Number 6 cases to 6, what do you call it? 6 cases here to arrange 2 identical and plus 1 distinct. But the problem is they are duplicates. Okay, you realize that these 2 are duplicates. These 2 are duplicates, and then these 2 are duplicates. Effectively, you only have 1, 2, 3 ways. Effectively, only 3 ways to arrange. Okay, understand? So how do we make sense of these 3 ways? Essentially, what is being nullified is the arrangement of these 2 identical balls here. You arrange 2 identical balls is 2 factorial, right? So to briefly explain, is the number of ways for this case here is 3 factorial over 2 factorial because you want to nullify the arrangement of the 2 identical. Okay, it's not really a satisfactory answer, I understand, but if you really want to go the rigor in it, you really need to list down everything lah. Then but I don't want to go but I think it's easy to understand. You just need to nullify the arrangement of the 2 distinct object. The identical object, you just divide by 2 factorial, right? So this case here is not 9 factorial. The number of ways here is essentially 9 factorial because you have 9 letters, 2, 4, 6, 8, 9, right? But you divided by 3 factorial because you want to nullify the identicalness of the 3 P's, and the 2 factorial because you want to nullify the arrangement of the identical 2 E's. Okay? The identical, what's the noun for identical? Yeah, identicalness. I can't really see identity also because it's not really identity, but the non-distinctness. Okay, I think you get the drift lah. So you do the second and third one.